Hello guys, so our topic for today is differential calculus. So after hearing the word calculus here, students would get feared generally. Fear not, while we at Learn JE are here to clear the fear. So differential calculus is a branch of mathematics that involves studying change in quantity with respect to another quantity. For example, in lower classes or even 11th, we would have studied acceleration. So what is acceleration? It is actually change in velocity with respect to change in time. So this change in particular quantity, that is velocity, and here another quantity we are talking about, that is time. So we are talking about two quantities whose change is the study we want to do now for this chapter. So this change is represented by d or delta. This d represents a very small change in velocity with respect to very small change in time. It's not zero, it is tending to zero. But then this is a very small change in quantities. So this is basically what we do in differential calculus. So another example, famous example, is velocity. And we study velocity as change in displacement with respect to change in time. So here it is represent S is displacement and T is time. So we are involving two quantities whose change we are talking about. So this is basically what we do in differential calculus. And second of all, what we do is there is an application, there is a very famous application, that is to find slopes of tangents and normals. So from our previous chapters, we know tangents and normals. So what is a tangent? A tangent is a particular straight line that hits the curve at just one particular point. And a normal is a perpendicular line that is perpendicular to the tangent. So we know these things. So consider a curve in the coordinate axes y and x. And consider the curve like this in a straight line like this, and let us say this hits at h comma k, and we know that this, let us assume the equation of the curve to be f of x. Now to find differential or differentiation, so what we do is we represent it with by f dash of x. So f dash of x is the differentiation of f of x with respect to some quantity, or in this case with respect to x itself. So here slope is basically the change in y coordinate. This is actually change in y coordinate with respect to change in x coordinate. So there is a small change in y quantity which leads to a small change in x quantity. So this is basically the slope of a given curve. Slope of a given curve at particular point x comma y. So assuming our point here is to be h comma k, so our f dash of x will be f dash of h. So basically this is the slope of the tangent that we are looking for. So after you get the slope of the tangent, we can directly find the equation of the tangent with slope point method. So it is y minus k, that is y minus y1, equal to m, that is the slope of the line, that is f dash of h, into x minus x1. What is x1 here? H. So this is basically the equation of the tangent. So now what is normal? Normal is basically what is slope of the tangent, slope of the tangent into slope of normal equal to minus 1. So assuming this to be this is true, so assuming you know this already, so slope of normal, m of normal, is minus dx by dy, or in this case it is minus 1 by f dash of h. So after you find the normal, we can easily find, after you find the slope of the normal, we can easily find the equation of the normal. Thank you.